We are going to go over what GreenWorx is, which is the perfect garage and high bay lighting retrofit solution for what we have available. Powerline Control Systems has actually been manufacturing lighting controls for over 20 years on the power line. We started using X10 technology and then advanced to use the UPV technology, which is in over thousands of homes throughout the United States and a variety of different countries, being used on 120 volt, 208, and 240 volts. GreenWorx is actually based on a newer technology called Industrial Powerline Communication, or IPC. And we basically created that to take care of the 208, 277 commercial space to allow control of different items. The big question that everybody keeps asking us is, what is GreenWorx? Well, it's pretty much the first fixture-level lighting control system to use the electrical power lines within a facility for actual two-way digital communication. We don't need any wires. So the nice thing is we can actually control stuff anywhere in the building. It's very, very simple to install. It's very, very well equipped to be set up for retrofitting existing buildings. We can actually get down to the fixture level control capability, where we can control each and every fixture in the building. We can actually define them as zones. We can create scenes for energy savings, for daylight harvesting, and it's very, the end user, the facility manager, can actually reconfigure everything once it's all set up within the facility. And GreenWorx is actually the only system that can do this without running wires to each fixture. Or, there are other technologies out there that you use wireless things, but you usually have to have a lot of repeaters, and unfortunately there's a variety of interference that goes on with RF type technologies. I always look at it as picture says 1,000 words. So what usually ends up happening in a facility is we've got multiple electrical panels that are running the lighting fixtures, and this is kind of more of a high bay aspect, but we have multiple levels on the on parking structures. So the first thing that is needed is our controller, which goes kind of at the main panel, what we call the GSC, the GreenWorx Systems Controller. At every sub-panel, we need what we call as an extender. And this actually are connected to the controller via a Cat5 wire to make sure that, depending on where the manual controls or input type devices, we can actually get the communication from whatever panel, wherever the input is coming from, back to the other panels, and the signals are sent at the proper time on the different phases, the 3 different phases. The second portion is a computer that is used to both configure the system, make adjustments, change things, and we can connect that computer or the software 2 ways. We can connect directly to a serial port right on the front of the GSC, or we actually have an IP-based version that has a USB connection on the front as well as an Ethernet. So the facility manager could actually be at his desk and connect with the software to his to the system on-site or off-site and make adjustments or change things. The next major part of the system is what we call as our fixture module. And the fixture module, we have a variety of different fixture modules that, depending on what kind of a ballast you have, could be a single unit, double 0 to 10 volts. We even have a 4-channel if you've got multiple ballasts. We also have wall switches that can handle the load. Instead of putting the fixture module actually up in the fixture, we can actually use a wall switch in the wall as well. The third part of the system is actual input type devices. Now we have an an input device here that can be connected to either a photocell or a occupancy sensor. And we have two versions of the input devices. One is a low voltage contact input, or we can have a high voltage contact input. One of the last parts is we actually have keypads. This is a 4-zone controlling keypad. We also have, well, this goes back to the input module, but we also have a smaller keypad which can control one zone. And we'll kind of go through these parts here in a moment. But what can GreenWorx do for you? One of the big keys is to help with daylighting. So in early morning in a parking structure, we can actually tell the two outside rows, and this is actually a floor diagram of one of our case studies called CSUN, which is California State University in Northridge. It's a 6th-floor parking structure, and this is actually a view of the 4th floor. Each one of these little squares represents a lighting fixture. And early morning, when the sun comes up, a photocell talks back to the controller, and the controller comes back and turns off the outside 2 rows. As it gets to be the middle of the day, we go and turn off another row, thus lowering the cost of energy. And then in the evening, we can go back and turn all of the lights on when the light is needed. And the last is late evening, where all we're doing is having the rows being controlled within the facility. Now, the nice thing is we can set up zones. They can be, as we're seeing here, a zone could be set up as the whole building. So we can have up to 250 zones set up within a system. So it's very, very flexible of what we want to be able to do. Now, in Michigan, this was a simple 80-watt induction type fixtures were around, and as you can see, each one of these has been numbered, and that's the way we know what fixture is what. This is a full-on scene on the 2nd floor. In this facility, the daylight harvesting side of it, when the sun is up, they've actually got, just 2 rows done, and then they want these 2 set up because of the stairwell. Late night in this situation is kind of every other unit. They also have schedules for midnight to 6 a.m. on the holiday nights, as well as weekend nights. So we can kind of set up anything, that you'd actually like to be controlled. Now, one of the case studies that we're going to show here is Cal State Northridge parking structure. And again, it's a 6-story facility. The overview within the job site was they did not want to relamp the whole facility. They wanted to continue to use all of the fixtures that were there. They wanted to obviously save on the electrical usage within the facility, reduce it by turning, the daylighting during daylight hours, reduce it during non-school working hours when a lot of the students were gone, really didn't need to have the lights turned on. They wanted to save up to 150 kilowatts, 150,000 kilowatts a year. And they wanted the payback of the system to be under 5 years. So, we had some target goals, things along that nature, and, the building, it's 73,000 square feet. It had almost 1,500 fluorescent fixtures. It had 47 HID lights up on the roof. It was 277 volts, 408 3-phase, and it's open to the public, 7 days a week. So, there's a lot of lighting aspects that, you've got to have a certain amount of light for the public. But at the same time, we want to turn around and save some energy here. The fixtures that were out there, they had 952 32-watt fixtures, 500 64-watt fixtures, and 47 250-watt fixtures. So they were consuming 58,000 watts of power. And what they were literally doing was turning the lights on and off with a mechanical timer. So at 5 p.m., they turned them on at 5 p.m. and off at 7 a.m., except for the emergency and the core lighting. So they were actually using 477 kilowatts per year at about, $66,000, almost $67,000, and that's on an average of 14 cents a kilowatt hour. Here in California, we do have a tiered rating, so they kind of vary day to day. By putting in the one controller, there were three panels and three extenders. There was one keypad installed, 1,300 fixture modules, and one input sense module to use the photocell. We actually, by using the photocell, we were able to step down the usage of power by 51%. We were actually able to save them almost 250,000 kilowatt hours, half of their cost down to $34,000, and the payback was under 3 years. So the reality portion of it was that we hit all of the targets and actually exceeded what they had planned, and we're very, very happy about the situation. Now, the way the system works is that you actually put a GSC, which is actually connected to a GSX as well, right at the main controller. And what we end up doing is the GSX connects to all three phases, and it will actually send signals out to the lighting fixture modules, which are out on the power line. So any light can be on any phase within the facility, and you would take a VSM, a voltage sense module, or an ISM, which is the low voltage input module, and they can be connected to your occupancy sensors, your photocells, and when the photocell gets to its setting, it will then go and send a signal down to the controller. The controller obviously has got, we preset things up saying, oh, okay, we've got enough light. So now it goes back out and sends signals to the different modules within the zones. I mean, all of the modules receive the command, but whoever's set up to be part of that zone or part of that command actually will then go ahead and turn on or off or go to the setting level accordingly. So it gets the signal back, and all of the devices basically around the skylight here turn off. So we can, do a variety of different things here. We have the GreenWorx systems controller, which is in a metal can connected to the electrical power. The front here is the front panel on this is actually the GSC part of it. The back part is actually the GSX. It's the main processor, does all of the, the heavy burdening, wires right up to a 120 or 277 volt panel, depending on what is in the facility and where it is. We can connect to it either via USB, Ethernet connection, or directly on this version that we're showing here is the RS-232. It can control up to 3,500 lighting fixtures. Each GSC can handle that many. There are actually 250 network IDs, so if you've got a facility that's over 3,500 devices, we can actually run a second network, or 3 or 4, and they can all actually be intertwined to communicate to each other. There's up to 250 user-defined zones that we can break down, and we can actually have 3 user-defined scenes per zone besides our default settings of high, medium, low, or off. It has an astronomical clock with daylight savings time capability in it, so we're not going to miss out on that. It also has a 20-year calendar built into it. And we can set up 4 user-defined schedules, which can run, every day, every other day. But there are 4 specific types of schedules that we can set up, and we'll explain a bit more of that as we go. Now, the thing is the GSC can connect up to 8 GSXs, but it has to connect to one exactly, so we can actually handle up to 8 different, 7 other sub-panels besides the main panel that the GSC is actually connected to itself. And it actually, you're configuring your whole system right through the GSC, so it's actually the access point to the network on the power. Now, the second device that we have is the GSX. So this would go on, all of the sub panels, and between it and the main GSC, you have to have a Cat 5, Cat 3, Cat 5, Cat 6 to communicate on an RS-485 bus amongst each other. It ensures that the signal gets on all of the panels on the right phase at the right time. Again, it's available 120 and 277, so you do have the capability of stepping down from a main panel of 277 down to 120, depending on the layout and the design. So this is kind of a typical representation. The GSX in here connects to the power. The GSC has got a ribbon cable that connects into your first GSX, and then between each of the GSXs, we actually have the Cat 5 RS-485 bus going between them. The zone lighting controller is actually the way that you can manually control different zones within your system depending on how you lay them out. So we can actually control zone 1. The defaults are high, medium, low, or off. However, you can actually, you select your zone and do, what you want to do. But you can also program each of those buttons to be whatever you actually want. So you could say turn on and off at 50%. You could disable, one of the buttons could be, don't turn, disables a timer event because you're running, overtime kind of a thing, or to start to trigger some sort of conditional logic. So the flexibility of what these buttons on the left do is really up to what the end user truly wants it to be. All this does is wire into hot, neutral, and a ground wire. This fits in a 3-gang standard electrical box, and it's controlling up to 4 different zones. Now, the zone wall controller controls a single zone, and this fits into a single gang box. So like if you've got an office space or an area of a warehouse that's, kind of a smaller room, what are the 4 things that I want to, 4 scenes that I want to create and control within that area, low, medium, high, or set them up again for what do you want those buttons to actually trigger the system to do. And again, hot, medium, hot, neutral, and ground. Now the FCM is our fixture control module, and again we have, it's communicating, it connects to the power, the line and the neutral, and this unit that we're looking at is a 2-channel unit, so we have the output on 1 and 2, but we actually have three versions available right now: a single channel, a dual channel, and a 0 to 10 dimming unit for your dimming type ballasts. And what's really nice is you can just go up into the fixture and wire this thing in. It's basically a remote control switch. So in this scenario, we've got the hot and the neutral, our ballast, and this ballast is handling 4 lights. We have so that could be like a single channel device. This could be a dual channel where we've got one controlling 4 and the other controlling 2. So we can in turn have a low, which would be just the 2 bulbs on, medium would be the 4 bulbs on, and then bright would be all 6 on. And we also have a dimming style where it's actually 2 channels because we can turn the primary on and off by turning the whole ballast on and off. But secondarily, we can then start to dim the dimming portion of the ballast. The GreenWorx wall switch, the GWS, again, it receives signals back and forth from the input and the controllers, and it will handle a full 20 amp circuit. It's just an on and off type device. Pull out your existing switch and install this. It is available. All of them are three-way, and we have a companion switch that can be also part of the system. So like in an office conference room or something like that, we can have two switches running the same device. Our input sense module is exactly that. It reports a class 2 contact when it's applied. This unit actually has 4 different channels. It can be tied into RF remotes, security systems, photo systems, any other of the building automation systems. We can take relay inputs into it. And each of the inputs is totally independently programmable as to if I get a contact in number 1, go do this. If I get an input into number 2, go do that. So it's very, very flexible to tie into any of the other systems. And again, you're just connecting power to it, line and neutral, and then our inputs, and then the last screw over here is the output. So very, very straightforward in the way of wiring. The voltage sense module is really the high voltage version of the input sense module. This actually will take 120 volts or 277 volt inputs, depending on what kind of sensors that the client actually wants to use. So occupancy and photocells. You can actually use just a standard, toggle wall switch to trigger things as well. And again, each of the inputs is independently programmed, and it sends all of its information back and forth over the power lines. So again, wiring it up, we can use a high voltage sensor input, hot and neutral, and this would actually kind of be a 2-stage photocell. When it gets to one level, we put one input in. When it gets to another secondary level, so all of a sudden we can do early morning and midday kind of a situation. So the GreenWorx software is really kind of the next portion of this. Marshall, have you joined us?
Yes, can you hear me?
Not really.
Can you hear me at all?
Now we go. There we go. We got you now. So what I'm going to do is I'm actually going to change the presenter over to Marshall. We are actually going to go actually connect to the CSUN facility and actually demonstrate how we can what the facility manager has the capability of doing, controlling things, checking things out. Marshall will kind of run this portion of it. Marshall is our CEO, CTO, invented the technology, and we'd like to thank him for joining. So I'm going to make the Marshall the presenter, and once he shares his screen, we'll be seeing things live.
Now, can you see my screen?
Yes.
Okay, this is we're connected to the software at Cal State Northridge, the actual 6-story parking structure right now live. What you're seeing is currently there's a PC in the electrical room of Cal State Northridge that is running GreenWorx, our software that you're seeing on my screen right now. In next week, the first of the system controllers that have an Ethernet connection, it's installed. It's waiting for the IT guys to hook it up so that there will not have to be a computer in the parking structure for us to remotely connect in. We'll be able to remotely connect in directly with an IP address and run the software on any computer in the world. I mean, the new product that we're introducing just now, in fact, all of the system controllers that will be shipped will have a USB port on the front for connection to a computer and an Ethernet port inside for connection to the facility's network. the ones that you've seen in the pictures in this PowerPoint so far show a serial RS-232 port, and that one's not being made anymore. So now you're going to see one that has a USB port on the front, which is just another form of the serial port that all laptops have now, and a Ethernet port in the inside. So we'll be able to remotely connect into all of our systems as long as the IT guys set us up and we have permission to. But right now, this demonstration won't be any different, except right now we're actually using remote desktop, Microsoft Remote Desktop, to connect to this PC that happens to be installed inside of this 6-story, 1,500 fixture parking structure. And so this part of the presentation will be sort of a review of an actual installation and the software that would be used to control and configure it. The GreenWorx software has several different functions. At the lowest level, it's just to control the lighting in the parking structure. And at the highest level, it's to configure and design the system. And because of that functionality, we have 4 different user levels. If you can see my mouse here, there's a little block here on the first tab called User Manager. And right now, out of the 4 levels, the 4 levels are first a user, the lowest level. The user can control the lights and look at the status of the system, but can't make any changes except to control the levels and see what's going on. Okay, that's the user. And we're logged in not as the user, but the second level, which is the facilities manager. The manager can not only do what the user can, which is to control the levels and see what's going on, but he can also change the schedules. So he can actually adjust the schedules for his own needs. The facilities manager can, but not the user. So if the facilities manager wants to let somebody be a user, he can, but that user can't change the schedules. Only the facilities manager can change the schedules. The next level up is the installer, which we're not logged in as the installer. The installer can design a system and set it up and basically change almost anything. The installer would be the same as the person that's commissioning it or configuring it. And then the last level we have is engineering, and that all of a sudden opens up a lot of diagnostics and test things and things that usually only PCS would use, advanced diagnostics and logging and things like that. And once again, we're not logged in as PCS. And let me close this. And the difference between being logged in as the user or manager, the way we are now, and in engineering, you're going to see a lot more tabs, and there's a lot more functionality that's hidden from view since we're only logged in as the manager. Okay. This is just Windows-based. There's no Mac version of the GreenWorx command control software. Now, again, this is live. This isn't a pretend thing. This is actually the Cal State Northridge parking structure right now. So just to review the basic functionality and why you would even use the GreenWorx system at all is to save energy. It's all about saving energy. For parking structures or high bay buildings, there's really no reason to implement lighting controls except to save energy, and as a corollary of saving energy is to meet code requirements. That's almost the same thing. You want to be able to meet the code requirements and you want to save energy. And of course, it saves money. You want to extend the life of the fixtures. Okay, so what we're seeing right here is a certain mode of operation, which happens to be the midday mode. But let's move to the second floor because it's a little cleaner than the first floor. And even though this is live, no one will complain if I turn more lights on, as long as I don't turn all the lights off at Cal State Northridge right now. So I'm going to be careful to not turn all the lights off, but I can turn them on. So when I do some of these demonstrations, I'm going to actually be changing the lights in this 6-story parking structure. To configure and control a parking structure, is conceptually very simple. You don't need very many zones and scenes to do what you're trying to do, no matter how big the parking structure it is, because you really only want to have different daylighting modes to save as much energy as possible with daylighting, and perhaps have some different time of use modes to save as much energy as possible with the different time of use scenarios. One is when it's being used a lot, and another one's when it's being used not at all. Those are the two extremes, and I'll just go through those. In this parking structure, they wanted the first floor to be a different, call it zone, because they want that to be on all night long, every night, no matter whether the parking structure of the school is closed or not, because for security and liability, and because people like janitors and late night people are going to usually park the closest they can to the school, which happens to be on the first floor, not the 5th floor, that the first floor is on even in the middle of the night. So, but what we're seeing right now is, let's go to the midday mode. This happens to be this mode right here, which is, I can activate it because it's already active anyway, which is the midday mode. Because in California it's 9:31, so and the sun has been up long enough that it's triggered the midday mode, and these outer rings are turned off. As you can see, this as it was explained in the other demonstration. Now, earlier in the morning, I'll just activate it here. You'll see that there's more lights on. There's another ring of lights in the perimeter that are on. Okay, and then that's what's activated in the very early morning. So as it goes through the day, it starts out, let's just start out with early morning. It's in this state where the 1 hour after sunup, in this particular installation, the lights are triggered such that the outer perimeter goes off. And then when it comes to be 1 hour after that, in the midday, another ring of lights goes off, further reducing the energy consumption. And then 1 hour before sunset, this scenario gets triggered and all the lights are on. Okay, so, and once again, this is live. I've actually just turned on 100% of the lights in the parking structure at Cal State North, except for the roof. The roof is a different zone and handled differently because it's HIDs. It takes 15 minutes to go on, so I'm not going to turn it on and off. And then that's controlled separately. So in reality, there's only 2 zones used in this parking structure. One is floors 1 through 5 right here, and the other one is the roof. You could make 10 zones or 100 zones, but you don't need to. So the object is never to make things more complicated than they need to be in order to achieve what you're trying to do. So with GreenWorx, you want to make everything as simple as possible to accomplish whatever you're trying to do, so everybody can understand. The user can understand it, the facilities people can understand it, and the designers can understand it. So you really only have 2 zones. We have these other zones here as a floors 1, 2, 3, 4, 5 are made set up as zones, but we don't control them separately. There's no reason to control them separately in this particular application. It's fine to control all the zones. I mean, all the floors are part of this one single zone, which we're calling floors 1 through 5, and they're controlled together. And it's simpler and more straightforward. Okay, and then the roof again is separate. So this scenario, 100% of the lighting on, is what happens just before, actually an hour before sunset, so that the lights are on when the school's being used all the time. Now at midnight, this is set up so that at midnight, this scenario happens where only the fixtures in the middle of the aisles are on. And it's hard to tell from here, but these fixtures are actually double fixtures. These are 64-watt fixtures in this row, and the two edge ones are 32 watts. So this turns out to save exactly 50% of the energy and produce 50% of the light, which is totally adequate. This parking structure is fairly overlit. And then that scene stays active until morning, until 1 hour after sunup, when it goes back to this scene, and this just repeats over and over and over again. This is what happens on weekdays. It's a little different on weekends because all the upper floors stay in the 50% mode. This mode all day on Sunday, not on Saturday because the school was used, but Sunday it's used very little. And so this mode is on all night on Sunday and holidays and when the school's closed, which is set up in the schedule. So again, this is the main way that we're saving energy. This scene we're seeing right now called Night Low is sort of a time of use scene, and these other two scenes here, I'll set it back to the way it's supposed to be since this is a real live parking structure. This scene in the midday is a daylighting scene, but the purpose of those two scenes is to turn off fixtures that aren't needed to save energy, and that's it. It's real simple. Okay, now that kind of is a review of the functionality with the live system. Now, just to go over the software a little here, these top tabs, System Controller, control the system. This is to control it, and the power meter shows you how much it's using right now, and this is calculated. This is not, there's no little real-time power meter in each fixture. It's calculated based on how the fixtures are set up in templates that define how many watts are used for the different levels. These fixtures here, like all of these fixtures, are just on-off. There's no dimming. They're not two ballasts. They're just simple on-off fixtures, fluorescent fixtures. So the power is either whatever that fixture is when it's on, or zero. So, and once again, like these fixtures, I can open up one of these. The one in the middle of the row here, I guess I can't do this in this mode because I can't get to the properties of a fixture because I am a manager. I'm logged in as a manager. I'm not allowed to go start altering the properties of the fixtures. I'd have to be the installer or engineering to do that. So I can't double click on one of these and show you what's inside because I'm the manager. But there are properties, and part of the properties is how much power that each fixture is using, and then this power meter is calculating the power, which is very close to the actual power in the parking structure based on which fixtures are on and off. The roof's totally off. These other ones are on some reduced level, so you can see how much energy is being saved. Also up at the top, it has the total power being used in a numerical form. You could also just put this in numerical form and see it in kilowatts instead of in a little bar graph. So you can go back and forth either way like that. And here's some other parameters. You can include the non-controllable fixtures. And here, some of these are non-controllable because they're on an emergency circuit and they're not meant to be controlled and they're on all the time. So if I turned all of these lights off, you'd see which ones are still on. But I'm not going to do that because it's a live installation. So let me stop and ask if there's any questions. I'd also like to, since this is the first GreenWorx webinar, understand how this webinar works if somebody asks questions. So can some attendee, Kim or Scott, ask me to talk?
Yes, Marshall. They have a way to type in a question if they so choose, or they can actually chat with me directly. At this point, we don't have any questions going on. And just so you know, we have about...
Can an attendee ask me a question?
Yes, they can, if they unmute themselves, and then they can actually ask a question. But most of the time on this, people end up typing in a question.
Kim, can you ask me a question?
Don't know if she's there or not. Just to let you know, we've got 20 minutes left, Marshall.
Okay, well, let me carry on. I just wanted to understand that if people did want to ask questions, how they do it and if they can. Okay, these other...
Marshall, Kim just texted me. Do you need to use the software to run the system, or does the GSC do that?
Can I see a text that's...
No. Marshall, the question that came in is, do I need to use the software to run the system, or does the GSC do that?
No, the software is not running the system at all, except for manual control when I go hit these little buttons and turn things on and off. The entire system, the schedules, the calendar, and I'll go to that right now, are all contained within the system controller. The system controller is like a giant intermatic time clock that runs everything by itself. The software is really meant to be disconnected, and normally you would never exert manual control over a system like this. It's designed to run on its own with the manual controls and the VSM, ISM controls and the schedule and the calendar, and the computer is not necessary at all for this to run. So, except it's the only way to see in and out of it. Okay, now, like for example, I'm going to go to the schedules. There's a calendar, a 20-year calendar where you can define up to 4 different schedules and then assign those schedules to any day of the 20-year calendar. We're only using 2 schedules right now. We're using one schedule. This blue schedule is the weekday schedule, and then we're using one that we're calling assigned to Sundays schedule, which is operating on both Sundays and holidays. So these holidays, the ones in the little red dates are holidays, and it turns out that this one, I think it's President's Day over here, the school isn't closed, so that one is still assigned a weekday schedule. But the other holidays like Christmas and Thanksgiving have been assigned to the Sunday schedule. You could have a holiday schedule if you wanted to make another 3rd or 4th schedule, but this particular system, to keep it simple, is only using 2 schedules. It's got the weekday schedule, and it's got the I'm closed schedule, which we're going to call the Sunday schedule. And the only difference between those two is that on the weekday schedule, the lights are on 100% until midnight, and then they go to this 50% mode where to save energy. But on a Sunday schedule, all the floors 2, 3, 4, 5 are set to the 50% mode all night long, since really nobody is using them. Okay, so this is the 20-year calendar, and this is just 1 year. This calendar is not in the computer. It's stored in the system controller. Everything necessary is stored in the system controller, inside of EEPROM or flash memory in the microprocessor that's running the system controller. It's not in the computer. You're just seeing it pulled out and represented on the computer, but it's not on the computer. If you go change something like, well, like if we wanted to change, I'm not going to save it, but let's say we decided this day the school is going to be open this Sunday because, let's say, for example, we decide that this day, June 9th, is graduation, when this thing is used a lot during the graduation days. So suppose this Sunday they're doing graduation and we decide we want to change that. So we assign that to a blue schedule, and then we would have to program it. I'm not going to do that because I don't want to save that change. But if you did want to do this, I'll just change it back. And then if I was the facilities manager and wanted to do it, I would make my changes in the schedule. And this is the calendar, actually. Let me close that. Let's say I made some changes. And then I would go, say I wanted to change when this midnight scene happens. It turns out here where it goes to night low is, wait a second, this goes to, oh, this is the Sunday schedule. Let me change it back to the weekday schedule. And then we'll see that here at 11:30, this scene gets activated. I could double click on that and I could change it to say, I'm going to make it 11:35. Okay, so I save that. Now I've changed it in the software, but I haven't programmed the system controller yet and actually saved it. So a little message pops up that says, you know, you changed it, but you didn't program it yet. That's what this message is saying. So I say, okay, I get it. Now I'm going to go to the system controller and save it. And when I hit save here, this is going to go actually load all the information that well, it actually loads all the information from the file, but I only changed one thing, 5 minutes, but it's going to program it all. And at the end of that, it's actually going to save the entire file, the Windows file, into the system controller also, as sort of a place to store it where anybody can get access to it.
Marshall, we've got two questions. One question is, what are the days in red on the calendar? And the second question is, can the system report if a fixture is not working?
Okay.
So if you wouldn't mind answering that.
I'll get to that. What it's doing right now is actually writing the entire Windows file into double EEPROM inside of the system controller. That's why it's a little bit slow. Also, this is a giant file because there's 1,500 fixtures. So a smaller file would be faster, and it's actually going to verify it too because that's just part of the process. Usually you don't do this step until you're going to close your software, you're done making your changes. And then, so it isn't like you continuously do this. So just be patient while this finishes resaving the file inside of the system controller into double EEPROM. Of course, if this was just saved to a hard drive, it would only take a second or a microsecond. But for security, we don't just save it to a hard drive because somebody could be doing this on a different computer. There could be several different computers controlling this, so it's actually saving it into the system controller, so everybody ends up with the same file. Now, to answer these questions, the red days were the holidays, and that's just sort of a notation. Let me close this. Let's go back to the schedule. These red days those are U.S. national holidays. That's why they're in there. Like here's Christmas Day, and somewhere here's New Year's, things like that. That's what the red is. And the other, what was the other question, Scott?
Can the system report if a fixture is not working?
Okay, there's a couple different aspects of that. This current system can report if a module isn't working. For example, let me see, I'm not sure if this level, the manager can do any testing. I don't think the manager can, but the installer can find out two things. With this system, you can find out if a module is not responding, in which case that module is defective. I'd have to log out and log back in as a manager, as the installer to do that. Or perhaps that should be one of the functions that the facilities manager can do. Let me see if that's in here. Here's the.
Look in the ribbon. Look in the ribbon right end under the.
Okay, right over here is a tab that says check the fixture ballast bulbs. These particular modules that are in Cal State Northridge have been in there a while, and they do not have the function that allows you to, effectively measure the current going out to see if the ballast bulb combination is correct. But the versions that are released, depending on if the customer wants this or not, can have that feature built in, which would allow you to check if the output of the module is correct within certain parameters that have been defined, which basically tells you whether the ballast and the bulb are doing what they're supposed to do, or if they're not drawing as much current as they're supposed to. And if they're not, then something's wrong and it probably needs to be checked or replaced. There's also I think I can show you with this, even though this should probably have an added feature that checks the existence of the module or not. But if I go over here to check the light level, let me clear the status of this. Now what we're going to do is check the light level, and if the module does not respond, you're going to see that it's bad. It's the same as telling you that it's bad, although it isn't written like that in the tab. But now, first of all, when you'll see these particular devices here that are still on, they're still yellow. That's because they're uncontrolled, and they're always on, and the system has no communication with them and assumes they're always on, but it needs to know that so that it can put them into the power, so that even though they're not controllable, they're still on, and the system assumes they're on. Okay, now I'm going to get the light levels of these tab fixtures just by clicking this, and a little message comes up and says 12 of these aren't controllable. That's the ones we're seeing over there, and 0 are not installed and 0 are marked as needing replacement. So it's going to go off and get the light levels of these modules, which is going to effectively tell you whether the module is responding or not, because the ones that can't respond you're not going to see, it's not going to get the right light level because the module won't respond. So let it finish that, and we'll see if any of the modules are bad on the second floor. I think there's a couple that are bad on here. And they will turn out to not respond, and they'll show a beam black in the end, which basically shows you that they need to be checked or replaced. And if they don't respond at all, they actually do need to be replaced. So let it finish trying to, this takes a while. This uses an enumeration technique, but it goes off and it tries to get the light level of everything. And a module either responds that it's off, responds that it's on, or doesn't respond at all. Now you'll see here that there are these two modules right here, this one and this one. And if I was see, this is number 423, and this is number 306. These modules, and here's one over here too. So there's 3 out of this, whatever, 200 or 300 that are not responding, and they need to be replaced. These modules are kind of an earlier generation and were built about 5 years ago. But and so these 3 particular ones need to be replaced. The other ones have all checked in, and they've all checked in as either being off or on. Now, there's a few that are off in this particular scene because there's more daylight available, and I think the scene has been set up. It's hard to tell, but there's these large wells in the middle of the parking structure where light can come down, and there's openings here so that a lot of light comes in. You can see that there's a pattern here where these are set up to specifically be turned off because there's more daylight available here. So, and I believe that when we activate this midday scene, those should show up the same way. Oh, those were turned on. So, there's something interesting going on there. The software thinks that they're on, but they're actually off because they're supposed to be off because there's a lot of daylight, and this has been programmed. And I'm not going to figure that out while we're talking. But in reality, a few more of these are off than the software believes are off when I hit this particular scene, and that will get investigated after this.
Okay, Marshall, we have another question here. It says, how do the modules measure the light levels? Is there a photocell in each fixture?
No, and one of the good things about GreenWorx is you only need 1 or 2 photocells for an entire parking structure, since the light is fairly uniform. In fact, that is the real value of GreenWorx, is that to instigate a scene for daylight savings or a scene for time of use, you just have to know what the light level is outside of the parking structure, which usually can just be done with 1 photocell. And if you wanted a different east-west for some reason to get really fine-tuned, which is kind of crazy, but it's possible, then you just need 2 photocells. And then what you do is you set up the scene to do what it's supposed to do for different daylights, and then the photocell triggers that scene. The most effective you need to be in any parking structure is to have 2 levels of daylighting, a high level and a low level. Normal photosensors really only have 1 level, but the one that we recommend is made by Intermatic, which has 2 adjustable levels, so it can really be fine-tuned to do 2 very fine-tuned levels to do exactly what you want to do. And plus you can go back and change it per engineering or design or whatever the customer wants. And which is what has been done here. When you saw that some of these other lights were turned off, that's because there's so much light coming into these wells that it's been determined that this interior section really doesn't need to be on. Some of these can be off near the wells, and that's what's done. And I'm not quite sure why the software thinks when it turns it on, when I just click on one of these, the software is updating the display based on the scenes that are stored in the software. But when I go off here and get the light levels, it's getting the actual light level. It is actually going out and polling them and finding out the light level. So there's some discrepancy between why this midday scene has this intersection on, but when you get the light levels, you find out that some of these are actually off. So that needs to be investigated. But
okay. The next.
Go ahead.
So what's the next thing that we can actually end up doing? So we can change the schedules. We can see what the light levels are. We know what's going on. What else can the facility manager do in the way of understanding how much power is being used?
I believe you can kind of check the time. There's some system controller functionality. This shows what is the time on the computer right down here, 9:55, the time in the system controller. They happen to match. But if they didn't, you could set them and just click on it, and it will change the system controller time to match the computer time. Something else is for astronomical time. This is within the system controller. You put in just one time the zip code, and this gives you the longitude and latitude, and sets up your astronomical times to use the correct longitude and latitude to determine sunrise and sunset. And when you open up this tab, this happens to give you sunrise and sunset for today, and this changes every day, of course. But this just shows you, for your own reference, what was sunrise and sunset. So when you make schedules, you kind of test them by seeing what time sunrise and sunset is today. And that's all the time tab is. Again, this is all in the system controller. I mean, this is not really in the software. This is just the software is letting you see into the system controller. That's the time right here. Another thing that you can do is kind of see a log, let's see, of what's been going on inside of in the system. So when these different things happen, okay, we're seeing a bunch of occupancy sensors which are actually disabled up here. There are occupancy sensors being tested at Cal State Northridge that are being disabled because we want them to control the occupancy sensor scene. But they are in there, and they're going off as people go up and down the floors. But this is just sort of a log, a little bit of an engineering thing that lets you see what's been going on. And if you go up, you'll see the scenes being triggered. Here's where these floors go to daylight morning. I think these are things that I did when I was demonstrating it. You see these different times.
Hey, Marshall, just so you know, we've got about 2 minutes of our of our scheduled time. So is there any kind of a wrap-up that you'd like to do, or does anybody else have any other kind of questions as to the functionality of what can actually be done? I know Joseph has asked a couple of questions here on things that we've answered. We are more than happy to explain that, but if people got to go, we totally understand that. One person left. It's okay.
Yes, I don't. Let me. Well, I could just leave it on Northridge here, but yeah, the main point we're trying to make here is that with GreenWorx we've designed a system where you can set up the appropriate zones and scenes within a zone to implement one or two stages of daylighting, which is the most fine-tuned daylighting that you can do, and get exactly which fixtures need to be on and off for the appropriate daylight that's available to save the maximum amount of energy. And also, you can see that you can set up the correct scenes and zones in order to do different time of use saving scenarios. And the only way to do that without rewiring the entire parking structure or running control wires is with some form of distributed lighting control. There's a couple wireless systems out there that sort of purport to be able to do the same thing, although we haven't really used those here at PCS, and how well they work you have to determine on your own. But all the distributed lighting controls have the same objective, which is to produce these fine-tuned scenes and scenarios for daylight savings and time of use savings. And our GreenWorx system, we believe, is the best system that for the least money and the most simple to set up the proper scenes and zones and schedule and calendar in order to achieve the maximum savings due to daylighting and time of use. And that's all there really is to do in a parking structure. And then it comes down to how reliable is that system? Does it work all the time? And another important aspect of it is what's the liability of something going wrong? That's something we haven't touched on, but it's huge in parking structure lighting control, is what happens if the system fails. We haven't talked about that, but if the system controller fails in this particular system, there's an aspect of both the system controller and the modules in that if the system controller quits talking to the modules for more than a certain setting, we have it set to 1 hour, then all the fixtures will come on and stay on until it's fixed. This is a liability thing. You never want the system to stay off when it gets dark or turn off when it is dark. So if this system ever fails, the lights will go on and stay on until it's fixed, which is a very important liability feature. Another thing is that if the power fails and returns for 10 seconds or 1 second or 10 hours, every one of these fixtures will go on when the power returns. The only thing that will get them back into a state they're supposed to be in, which is some form of reduced lighting, is either a schedule going off or a photo sensor control going off or a setting in the system controller, if it's active and working, that says go back to your previous light level. And that can be set up within the system controller. But once again, at PCS and GreenWorx, we've thought about the liability issues a lot, because from the customers we've talked to, it's really important that you really address the liability issues, because that's one of the main concerns of trying to control lighting. Otherwise, you just leave it on 100%, which solves the liability issues but doesn't save any energy. So if you are going to implement controls, you better talk about what's going to happen when the power goes off and comes back on, or what happens when the main controller, whether it's wireless or power line, fails, and we have thought about that and built that into the system.
Okay. Do we have any final questions or thoughts? Okay. Joseph, I'll contact you shortly, and we can set up another meeting. Other than that, everybody else, we would like to thank you for your time and attending the GreenWorx overview. And we look to see you at another webinar shortly. Hope you're having a great day.
Okay, bye.